Hello, this is Mr. D. Let's get started into chapter 4. I'm going to combine 4.1 and 4.2 together as it's stuff that's got some tricky things in 4.2, but 4.1 doesn't have enough for us to spend one full day on it. So I'm just going to kind of hit that and move on into the trickier stuff in 4.2. So it's going to take a couple videos to get through that for us. So in front of you should be these notes. Put your name and date on it if you have not yet done that. And let's just start right here at the beginning. Question says, what are the variables in this graph? Describe how the variables are related at various points. And they're going to kind of talk us through those questions here as we go down the page. And the variables, when given a graph, there's three things that should always be on the graph: a title and the two axis. And basically your axis are the variables. Okay, so that's a variable. The y-axis, variable, and this is a variable as well. And so down here, number 9, it says circle the two variables being related in this graph. Well, we have time, the x-axis. By the way, that x-axis is the independent variable. We're going to see that really in the next section, in section 2. And the y-axis is the dependent variable. And that's important that you know which one's which. And so time is independent, and length, in this case, is the dependent variable in that particular problem. All right, moving down the page, we'll continue answering these questions, and hopefully it's making sense to you as we go. It says, show how the variables are related by underlining the correct word or words that complete the sentence. So here it says, the length of the board increases/decreases with time. So you're looking at this board here, and as time increases, okay, so it's talking about with time, as this variable, as the independent variable goes up, what happens to the length of the board? And it decreases. It should be obvious by looking at it. But as we learn to read graphs, the thing that you want to realize is we read it left to right, just like we're reading a book. And we ask ourselves, how is this changing as the independent variable increases? Hopefully you've seen this in science a little bit, and it overlaps nicely there. So let's continue answering these questions. As it says, the length of the board is constant or decreasing while you're actually cutting the board. And hopefully you can see that each time you cut the board, the length of it decreases. The dependent variable goes down as the independent variable goes up. During the time shown on the graph, it says there are 3 or 4 cuts. Well, let me erase my markings here, and let's make sure we can get a nice look at what's going on in this graph. We look at that and we see, hey, there's a cut right there, right? There's a cut right there. There's a cut, so I see 3 cuts on that board. And then the last thing it says that there is or is not a piece of board left at the end. So right here, it looks like there's something left because this part right here would be where 0 is. So since there is a gap above the x-axis, there is a piece of board left at the end of this particular graph. So that's really what 4.1 is about. It's about reading a graph and interpreting it and realizing that a graph is really a story. And you read a graph left to right and you figure out what is happening over a period of time. Again, hopefully something you've done enough where we can go fairly quickly through it. Here's a nice another example right here of June and a cell phone. And our two variables here are cost and number of minutes. So as you read this graph, you're reading it like this. As this goes up, as the number of minutes goes up, you're making an observation of something that's happening to June's cell phone. It says show how the variables are related by underlining the correct word to complete the sentence. And it says the cost of the cell phone in June increases or decreases. And I think I was saying June as a person. It's June as the month of June is what it really is. Let's see, it looks like, well, as the cost of the cell phone in June increases or decreases with the number of calls. Well, it's interesting because it's constant, but then it goes up. So over the full period of time, we would say that it increases because it does increase after a certain period right here. Now you, who are probably familiar with cell phones and cell phone plans, can probably figure out what's going on at this point in time right here. There's a story happening here. The cost of the cell phone in June is constant or increasing for the first part. Well, clearly the first part, that's a constant value. So that means they haven't hit their total number of minutes. And again, you can kind of see the story here that they pay a constant fee, a flat fee, up to a certain number of minutes, and then they have to pay per minute as they go. So that takes us to number 12, and it says, how are the variables in the, describe how the variables in the graph are related. So you might say, you would tell the story here. Well, the first part of the month, okay, the cost is constant. Now you could have something slightly different as you describe it as long as it's accurate, but that's the main idea. They have a constant cost at the beginning of the month, and then the second part of the month, okay, the cost increases steady after a certain number of minutes. And that kind of tells us the story briefly about what's going on in this particular graph. So that's a piece of chapter section 1, and then a couple other things out of there. This is the same idea here, interpreting maybe a table as well as a graph, because what we're going to do in this 4.1 and 4.2, our objective is to observe how does a table and a graph and an equation all show the same amount of material or the same material, and what might be the advantage of one versus the other. And that could all depend on what it is we're trying to do with a particular problem like this. It says this table shows an amount of sunscreen left in a can based on the number of times that the sunscreen has been used. So here we have a sunscreen bottle that's been used 0 times. It's got 5 ounces. And here it's been used once. And notice it has 4.8 ounces. Then they use it again. It has 4.6. And they use it again and they have 4.4. That says, well, which one of these graphs accurately represents this table? Well, let's look at A. In this graph, it looks like it is used 4 times. And when I look right there, it looks to me like the bottle should be empty, because it's at 0 on the x-axis, and that's not what's happening here. After the third use, it's been used 1 time, 2 times, 3 times. I said 4 a minute ago. It's been used only 3. After 3, there's still over half of the bottle left there, so it can't be A. Well, according to B, it looks like they used maybe a little bit the first time, because it only went down from here. It just went down a little bit, and then it went down a little bit more, and then it went down more. But as I look at this, okay, it looks like they lose 2/10 of an ounce here. And if I look here, it looks like they lose 2/10 of an ounce. And I look here, they lose 2/10. So to me, the decrease is more steady than B shows. So let's look at C. When I look at C, it looks like that decrease is pretty similar each time. So I think that C is our best answer to the graph that probably most accurately shows that particular table. And so let's move on down and let's see if we can answer these questions and see if it agrees with what we've said. It says, analyze the data in the table and complete each statement with the correct choice from the list. Use each word only once. So they gave us 3 words here: slowly, fall, and decreases. And they're saying which word fits into these particular sentences. The amount of sunscreen in the container blank after each use. Well, it decreases. And so we put decreases here. It decreases after each use. The amount of sunscreen in each container changes slowly. And the graph should fall at a slow rate. So again, they're just trying to get you to look at something and be able to tell and articulate the story from the table. So the last part here, as we wrap up this video, it says sketching a graph. It says suppose you start to swing yourself on a playground and you move back and forth, swinging higher in the air. Then you slowly swing to a stop. What sketch of the graph would represent how high you are from the ground, that it might change over time? Okay, so here you are on a swing. Here's a swing. Here's a nice little chair, and you're sitting on the chair, okay, and your feet are slightly above the ground, and they pull the swing back, and they are measuring how high you are off the ground as you swing. So they pull you back and they let you go, and you swing there and there and there, and then you slowly come down to a stop. So it's saying the two variables being related are time. So time, if we were going to sketch this, we would have time. Here, time is going up this way. And you're sketching how high are you, your height. Okay, so the two variables are time and height, D. And then it says, consider after 3 cycles during the middle of your time on the swing, circle the best sketch from your height during that time. Well, let's look at the first one. Does that make any sense? As you are pulled back and swung, would your height stay the same? It's clearly not number 1. Number 2 says you start high, swing low, and end high. I don't know. Let's think about that. We'll come back to it. But the third one says you start low, and then you swing high, and you end low. Okay, so you start low on the ground. Well, you would start low because you would start here, okay, and then they would pull you back high, and then they would let you go this way, and you would end up being low. So this particular height, your height would increase a little bit, and then they would let you go and you would swing a lot, and then they would let you go a little bit more there. So I think that this one is the one that best shows this particular graph for us. So it's just an observation of interpreting a graph, and hopefully that makes sense to you. So I went a little bit long in this video, but that wraps up 4.1, and then the rest of the time we will look at 4.2 in the next video.